Hello everyone, my name is Daniel, and in this video, me and my team will be presenting our project titled Basic Network Design and Implementation for Sekolah Kebangsaan Senawang. Sekolah Kebangsaan Senawang is a primary school that relies on a computer network to support daily operations such as administration, teaching, printing, and data management. A well-designed network is important to ensure stable communication, easy access to shared resources, and efficient management between the different departments in school. The main purpose of this network is to allow devices such as computers, printers, and servers to communicate with each other securely and efficiently, while separating different areas like the administration department and the teacher's office. Okay, based on this diagram, the network uses a star-based topology where devices are connected to switches and the switches are connected to a central router. The router acts as a core device, allowing communication between different parts of the network. On the left side, we have the administration department. This section includes multiple PCs, a printer, and a server, all connected to a switch. The switch then connects to the router using a default gateway of 192.168.4.1, allowing all devices to communicate within the network. And then on the right side, we have the teacher's office, which also uses a switch to connect several PCs and a printer. This switch is connected to the router with a different default gateway 192.168.4.129, ensuring proper traffic flow and network organization. This topology is suitable for a school environment because it is easy to manage, scalable, and reduces network failure, since a problem with one device does not affect the entire network. Well, that concludes the introduction and topology overview. Let's move on to the next section.
So for our next part, I'm Sophie. I will be presenting about IP addressing and subnetting plan. For our subnet, since our project has only 2 LAN, we will use only 2 subnet, and the most suitable subnet mask for our 2 subnet is 25, and each subnet has a total of 428 hosts. For our project, our original IP address 192.168.4.0. Based on our network table, for our first subnet, we have original IP address with 192.168.4.0, and the host ID range is from 0.1 until 0.126. As mentioned before, for first subnet we have 126 hosts, usable hosts, and our broadcast ID is 192.168.4.127. For our second subnet, the network ID start from 1 to 8, and the host ID is start from 1 to 9 until 254. With broadcast ID 192.168.4.255. For our topology, for each of our end user IP address, we will start with our server on LAN 1 with server PT server 0 with our IPv4 address 192.168.4.2, and continue with our PC0, continue with our printer 0 192.168.4.3, and PC0 192.168.4.6, and PC1 192.168.4.7. For our second LAN and our second subnet, we have the first one is printer 1 192.168.4.130, and continue with PC2 and with 135, PC3 and with 136, and PC4 and with 137. And all of our subnet mask is 255.255.255.128. and we leave some of our IP before address. We leave some of them empty because so the school can add more devices for each of our subnet.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rajab for Syahir bin Rajab's Lab. I will continue to phase 3, which is configuration. I will explain how we configure the device to match the addressing table we just discussed. We start with our router. First, we secure the identity of the device by setting the host name school router. And we configure the interfaces by departments, which is admin department on the left. We assign 192.68.4.1 to interface G0/0/0. Next is on the right, teacher's office. We assign 192.168 interface G0/0/1. Next is DHCP configuration. We configure DHCP pool so the computer get IP address automatically. We created admin pool for the admin network. Next is switch configuration. Configure two switches, name them admin switch and staff switch. To verify our connection, we use the command show interface status. As you can see and in our documentation, listed are connected. Please confirm that layer 1 cabling is correct and the access port are active. For any devices, we configure the IP address by using static, which is manually insert for server and printers, and user PCs are set to DHCP for flexibility. Finally, the phase 4, which is testing and verification. To prove that our implementation works, I have recorded a short demonstration of the network connectivity. I'm using a filter XMP. Here we want to ping from the PC1 to PC3. We ping by set the PC3 IP address. Switch PC, and it will reply. The result is reply from PC3 to PC1. From here, source IP address is from the PC3 and the destination IP address for PC1. In conclusion, the IP configuration checks confirm that our DHCP pools are working correctly and our ping test proof full connectivity. It's the entire school network. That concludes our presentation on the implementation for Sekolah Kebangsaan Senawang. Thank you.